Welcome to DSA Primer Series Episode 3. My name is Harinder. We had 2 sessions. उसके अंदर हमने डिस्कस किया है टाइम कॉम्प्लेक्सिटी एंड स्पेस कॉम्प्लेक्सिटी. Okay. We took Fibonacci and Factorial के example and we tried comparing their iterative and recursive version. Right? We computed time complexity and space complexity and identified which one is better. Okay. वैसे तो हम जो भी कोड लिखने वाले हैं पूरे प्राइमर सीरीज के अंदर, we will be discussing space complexity and time complexity for each and every code. So by the end of this series, you will be experts in calculating the complexity. But for now, let us spend some more time complexity practice करने के लिए. We will try some simple problems for that. ठीक है? So this is the agenda for today. These are 3. पेपर सीधा कर लूँ ना. These are 3 code I've written. Okay. आलस में मैंने फंक्शन के नाम नहीं लिखे हैं, but you can assume each one is one function. We will be computing time complexity for all of these 3. If you remember, हमने फर्स्ट वीडियो में एक्चुअली में यही 3 करे हुए हैं. Okay, and we have computed the time complexity. This is just a quick revision. So this over here runs for unit amount of time, you can assume. Okay. And this line will run for n square number of times, because when I is 0, j will run from 0 to n. When I becomes 1, j runs from 0 to n again, right? So n into n comes out to be n square. Time complexity of this code is n square. Okay. If you need more details, you should go and check the first video. Okay. This over here runs for n number of times. So this is n. This runs for m number of times. So this is m. So time complexity comes out to be order of n plus m. ठीक है. इस केस के अंदर आई कैनॉट राइट n और m बिकॉज वी डोंट नो व्हाट n इज, वी डोंट नो व्हाट m इज. m भी बड़ा हो सकता है, n भी बड़ा हो सकता है, राइट. Another way of writing this is big O of maximum of nf, n comma m, right? This we have discussed in the first episode. Okay. Over here, this runs for unit amount of time. Again, n iterations. This is again n square iterations. So you add these two, comes out to be big O of n square plus big O of n, or you can also write big O of n square plus n, which comes out to be big O of n square. ठीक है. बड़े भैया हमेशा जीतते हैं. So this is good. So this is another example wherein I starts from 0, I go till n, I plus is equal to 2. ठीक है. So let us take examples. Whenever we are confused, take examples. Okay. So suppose n is equal to 4. When n is equal to 4, I starts with 0. Okay. 0 is less than 4. Yes, 0 is less than 4. It will go inside. Okay. Then I becomes 0 plus 2, which is equal to 2. यहाँ पे I plus is equal to 2 is another way of writing I is equal to I plus 2. Okay. So I becomes 2. 2 is less than 4. Yes, 2 is less than 4. It will go inside. Okay. Comes back. I becomes 4. Right. Is 4 less than 4? No, 4 is not less than 4. So it will not go inside. So it will basically run for 2 times. Okay. Similarly, when n becomes 6, I will be 0. 0 is less than 6. Yes, it will go inside. I becomes 2. 2 is less than 6. Yes. 4 is less than 6. Yes. 6 is less than 6. No. Okay. Run for 3 times. Similarly, when n becomes 8, you can figure it out. It will be 4 times, right? Now, if I call number of iterations as k, तो k comes out to be n by 2. कैसे? अगर ये k है तो यहाँ पे n is 4, k is 2, n is 6, k is 3, n is 8, k is 4. So that basically means I can write n is equal to 2 into k. Okay? If n is equal to 2 into k, k is equal to n by 2, and k is our number of iterations. Okay? So time complexity of this comes out to be big O of n by 2, and if you remember the first episode, we can write it as big O of n. Okay. Coming over here, again taking examples. If n is equal to 4, I is equal to 4, because I starts with n over here. Is 4 greater than 0? Yes, 4 is greater than 0. It will go inside. Comes over here. I becomes 2. Is 2 greater than 0? Yes, 2 is greater than 0. It will go inside, comes over here. I becomes 0. 2 minus 2 is 0. 0 is greater than 0? No, 0 is not greater than 0. So this is 2. Right? When n becomes 6, it will be 3 times. 6, 4 and 2. 0 is not greater than 0. Okay. N becomes 8, it will be 4 times. Again, you can write n is equal to 2 into k, and then k is equal to n by 2. Okay. The time complexity of this code again comes out to be order of n by 2, which is equal to order of n. Okay. In fact, if you look at D and E closely, you will realize it's kind of same. If this statement is same, then both of those things are doing the same thing, right? It's just that वहाँ पे वो 0 से लेके n तक जा रहा है, incrementing 2 every time. यहाँ पे वो n से 0 पे जा रहा है, decrementing 2 every time, right? They're both kind of same, right? There's one important thing I want to mention, right? Writing this code for int I is equal to 0, I is less than n, I plus 2, इसका टाइम कॉम्प्लेक्सिटी ऑर्डर ऑफ n आता है. Okay? Similarly, अगर ये 2 की जगह 1 लिखा होता, okay, उसका भी टाइम कॉम्प्लेक्सिटी ऑर्डर ऑफ n ही आता, right? Because this will run for n number of times, right? So you can say time complexity of both of them are same, right? That does not mean practically they will take same amount of time, right? This one is n by 2 iterations. With I equal to I plus 1, it will be n iterations, right? So technically, practically, this code with I equal to I plus 2 will take half amount of time than the code which is I is equal to I plus 1, because it is running for n iterations, this is running for n by 2 iterations, right? So practically, your program may take more or less time, right? And therefore, I mentioned earlier as well, time complexity does not tell you the amount of time your program will take, right? It just tells you the how your time will grow according to the input, right? Over here input is n, okay? तो यहाँ पे अगर n डबल हो रहा है तो टाइम डबल हो जाएगा, n 4 टाइम्स हो रहा है तो टाइम 4 टाइम्स हो जाएगा. दिस इज व्हाट वी आर डिस्कसिंग ओवर हियर, एंड हेंस टाइम कॉम्प्लेक्सिटी ओवर हियर इज ऑर्डर ऑफ n फॉर बोथ ऑफ देम, राइट? अगेन आई एम जस्ट रिपीटिंग, two algorithms having same time complexity does not mean they will take same amount of time, okay? They may take different amount of time, and practically it is different, right? Practically 4 सेकंड और 2 सेकंड में बहुत फर्क है, okay? 4 मिनट और 2 मिनट में बहुत फर्क है, okay? Anyways, moving ahead, let us take couple of more examples, right? So now what I have done is यहाँ पे I is not I plus 2, यहाँ पे I is equal to I multiply by 2, right? So we are multiplying by 2 this time. Okay. Again, take examples. Okay. Say n is equal to 4. When n is equal to 4, I is equal to 1. I is less than 4. 1 is less than 4. Yes, it will go inside. Okay. I becomes 2. 1 into 2, 2. Is 2 less than 4? Yes, 2 is less than 4. It will go inside. I becomes 4. Is 4 less than 4? So now if you continue, you will see when I becomes 4, 4 is not less than 4. Okay. Hence it will not go inside, and therefore it will run for 2 iterations. So when n is equal to 4, k is equal to 2. Again, remember, k is basically, I'm calling number of iterations as k. Okay? It will help me to calculate k, right? Let us take example of n is equal to 8. Okay? So I is equal to 1. 1 is less than 8. Yes, it will go inside. I is equal to I multiplied by 2. I becomes 2. 2 is less than 8. Yes, it will go inside. I becomes 4. 4 is less than 8. Yes, it will go inside. 8, no, 8 is not less than 8, तो ये 3 हो गया. n 8 पे ये 3 हो गया. n को हम 16 लेते हैं तो ये 1, 2, 4 और 8 पे चलेगा, 4 बारी चलेगा 16 पे, ठीक है? तो इसके अंदर नाउ वी नीड टू कैलकुलेट k जस्ट लाइक लास्ट टाइम, ठीक है? हाउ डू वी डू इट? अगर हम बिल्कुल गहराई तक देखेंगे, ओके, तो यू विल रियलाइज कि n ओवर हेयर इज इक्वल टू 2 raised to power k. It is not 2 into k like last time. It is 2 की power k. 4 is equal to 2 की power 2. 8 is equal to 2 की power 3. 2 into 2 into 2 is equal to 8. Similarly, 2 into 2 into 2 into 2 is equal to 16. ठीक है? So n is equal to 2 की power 8 is equal to 16. तो यहाँ पे n is equal to 2 की power k हो गया, ठीक है? तो k क्या हुआ? If you remember your 9th class mathematics, I don't know, taking log base 2 on both sides, it becomes log base 2, n is equal to log base 2 to the power k. it becomes log base 2 n is equal to k बाहर आ गया log 2 के बाहर कैसे आया? If you don't know this thing, you should remember that log a की पावर k is equal to k log a, फ़र्क नहीं पड़ता बेस कुछ भी हो, बेस ये एक लॉगरिथमिक का फॉर्मूला है, you should remember. Now log 2 base 2 1 हो गया, कैसे 1 हुआ? अगेन log a base a is equal to 1, ये भी एक लॉगरिथमिक का फॉर्मूला है, you should remember. So it comes out to be k is equal to log n base 2. Okay, so if you don't want to remember these two, you should remember these two, but another formula which you can remember is if n is equal to 2 की power k, then k is equal to log n base 2. बेसिकली यहाँ पे a लिख देते हैं, n equal to a की power k, तो k becomes log n base a. ठीक है, you can actually prove it the same way I have done. You can take log base a on both sides, so ये निकल के आ जाएगा, right? So now what we are basically saying is कि this will run for log n number of times, right? So hence time complexity of this comes out to be log n. Okay. In an interview you can say log n, you don't need to mention base as 2. This is by default. Computer science के अंदर if I'm not mentioning base of the logarithmic, people assume it is 2. Similarly physics के अंदर if you don't mention the base, people assume it is 10. Okay, by default. In case of computer science we assume it is base as 2. If it is anything other than 2, that means you need to mention that, right? Log n base 3, right? Or log n base 4. But in this case, you can just mention it is log n, right? Or log n base 2. Both works, right? Similarly, this one is similar to f. Okay? I am leaving this as an exercise. You should compute it yourself. The time complexity of this thing should again come out to be log n with base as 2. Okay? Last but not the least is h. h is important because हर इंद्र में h आता है. Okay? तो यहाँ पे अगेन टेक एग्जाम्पल, तो i is equal to 0, अगर n को हम 4 ले लेते हैं, 0 less than 4, yes, it will go inside. I becomes, oh, I is equal to I plus 0. I becomes 0, 0 less than 4, yes, it will go inside. I becomes 0, 0 less than 4, yes, it will go inside. Tuck, 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 tuck. This will never end. This is infinite. Time complexity का मतलब नहीं निकलता. Okay? This program will never end. ये बेकार है. Okay? There is one more thing I want to mention before we close for this session. Okay? Is this. So this is called as constant time complexity, right? So when someone tells you that the program is having constant time complexity, that basically means order of n, right? Logarithmic, linear, polynomial. Over here a is a constant, it can be 2, 3, 4, whatever. Okay, again a is a constant. This is exponential. Okay, constant is better than logarithmic, which is better than linear, which is better than polynomial, which is better than exponential. Of course इसके अंदर और भी हो सकते हैं, ऐसा नहीं है सिर्फ यही varieties हैं. You can have something like n log n, which can be somewhere over here if a is equal to 2, basically greater than equal to 1, or it can be anything, right? You just need to take examples and realize and figure out which is better, right? But in general, you can assume this is what this is how the time complexity is, and these are the main categories you can divide time complexity into, right? That's it for today. We'll keep it short. I hope you liked it. Okay, sayonara, tada.